So the have started production. It's going to be about a week, maybe two, until I have them in my hands. To speed things up so that I can actually work on the firmware, I'm going to create a simplified version of the schematic, etch it myself and assemble it so that I actually have something in my hands I can use to test out the bootloader. So I've started by saving this as version 0.4. The previous version was version 0.5, and I'm just going to basically strip out parts of the schematic that are unnecessary and quickly reroute the board. So I'm not So here I'm busy getting things set up to etch the boards. I've printed out the patterns onto transparency. It's better if the transparency is actually transparent. These are pretty bad quality ones that are a little bit misty, but they work just fine. So I have my top and bottom layers here. Because it takes some time, I'm busy heating up some water on a hot plate here. So I've got a bunch of water that's at boiling, and then I have some water which is warm but not quite boiling. And I'll mix it to get the right temperature. So this one is at 56 Celsius at the moment, which is just about right. You'll see later what we want to keep our mixture at about 55 Celsius or 54 Celsius. So the first step is to develop the image onto the boards. So I have a bunch of chemicals and equipment from MG Chemicals. They have a kit. They sell everything: the chemicals, the UV light that you can use for exposing it, pre-sensitized boards and whatnot. So I've got this light here. This is essentially a daylight bulb inside a little stand that sits above the workspace, and I'll plug this in. And I'm going to take my patterns here and take one of the layers and just cut off some of the excess on one side or one corner. And I'm going to take the two patterns and using the fiducial prints. So firstly, obviously, make sure that you have them the right way. Your holes should line up and your fiducial should line up, so that's clearly wrong. There's only so many possible ways. Okay, so you get the fiducials to line up nicely, and then I'm just going to take some tape and tape along the top there so that they don't slip. I used to use staples, but staples have a bit of slack in them, and that can cause problems with finer traces. So we just get this to line up. This particular board is not very sensitive, so we don't need to worry too much, but that's basically fairly well lined up. So now I'm going to take this PCB. This is a double-sided pre-sensitized PCB, and it's got a sticker on it that you need to peel off. And underneath the sticker you can see you have your pre-sensitization. This is what we're going to essentially expose our pattern onto. So I'm going to take this PCB and put it between the two layers of transparency here, and then I'm going to sandwich that in between two thick, heavy sheets of glass. Once I've done that, I'm going to turn on the light and expose it for 6 minutes on each side. It's worthwhile to move the light around a bit so that you get equal exposure. While that's busy developing, I'm going to prepare the developer. So I've got some room temperature water here, 500 milliliters of it. I'm going to mix it with the positive developer in a 10-to-1. So 50 milliliters of the hydroxide to 500 milliliters of water. We'll set that aside in a container that we can use to put the PCB in and develop after we've exposed it. So this method is actually quite easy using a pre-sensitized PCB. It costs a little extra. The method I used to use was toner transfer. You just get blank copper PCBs without any coating on them, and you would print out your pattern onto transparency like this and iron the toner off the transparency onto the PCB. And that works relatively well. I think my yield was quite a bit lower than this, but it was quite fast, and the materials were much cheaper. If you have the available money though, I would recommend going for pre-sensitized PCBs and exposing them like this. It's substantially easier and you get much better results. If you have a double-sided PCB like I do, where one side has substantially less detail than the other, for example, this is our top layer which has quite a lot of detail, and this is our bottom side which has hardly any detail, and you're not very good at getting just the right amount of time during your exposure process, it's best to overexpose the side with less detail, so it will basically etch faster, so that you can, by the time that this side is done and you have just the right amount of etching done, you know that you don't need to wait for this side. If you overexpose this, you'll get some voids in the copper and whatnot, but it's not a problem on this side. If you overexpose this side, some of these thinner traces may no longer be fully connected, and that'll ruin the board. So overexpose your easy side so that your hard side can be controlled carefully. Now that this side is nearly done, basically I'm going to just flip it over. Hold the two glass sheets together quite strongly so that your pattern doesn't move around too much. Flip it over and line it up for the other side. So to get finer control over the process, I'm only going to do this side for 5 minutes, so that when I'm etching it later and developing it, I know that I can stop as soon as this side is done. So now that this is sufficiently exposed, I'm going to remove the light source. And remove the board from between the glass layers. Now I'm going to wash the board in the hydroxide positive developer solution until the developer or the resist washes off. The speed at which the resist washes off is dependent on how long you exposed it to light, and also somewhat on the temperature of the water. This water is perhaps a little on the cold side. You should see the pattern starting to emerge. You can also see on the right hand side of the board here the effect of the transparency not being completely transparent. Where the transparency wasn't present, it actually developed substantially faster. It's probably worthwhile me trying to locate a better quality transparency so that I can get better resolution in my design. And despite my best efforts, it does appear that the detailed side is developing faster. So I'm going to stop agitating the whole board and just using a brush wipe the side that I would like to speed up. You may be tempted to stop when you get to a stage like this and you can clearly make out the pattern. Unfortunately, if you do that, it makes the etching very difficult. There's still very light shadows of green on the board here, and the green etching resist here is actually very powerful. Even a very thin layer of it can substantially slow down the etching in that area of the board. So it's better to overdevelop it here until you have everything fully removed, so you don't have as much pain during your etching phase. That's looking about right. The bottom side here, you can see there's still a bit of a shadow, but it's off the boundary of the board, so it probably won't cause too much problems. And on this side, things are starting to look pretty good. I don't see any significant shadow left here. So at this point, I'm going to stop it, and I'll leave a little bit of a shadow around the sides here so you can see what it looks like later when you're etching. So let's move this out the way. I just have a container of plain tap water here that I'm just going to rinse the board in. Rinse the surface of the board off, and I'm just going to leave it in here while I prepare the solution for the next phase. If you've spilt hydroxide on the table, at this point it's worthwhile cleaning it up before it leaves a mark. This is a rubber anti-static mat. It's actually relatively resistant, but if you spill this on wood or something like that, it'll turn it brown in about 2 minutes. So for the next phase, we're gonna make a solution of sodium persulfate for copper etching. So essentially I use 125 grams and 500 milliliters of water, you know, plus minus. Science. I highly advise wearing gloves. This stuff is not very friendly on your skin. And now the guide that they give you, this works better if the solution is warmer, but there's all sorts of warnings about not exceeding 55 Celsius. I don't know what happens, but I assume it's bad. So I normally work at 54 Celsius, so it's as fast as possible, but it's still not going to cause any big problems. And now by weight, I'm just going to add 500 milliliters of water. This is the water that I have before. It's warm, but not hot. So it's at about 50 Celsius, and that's fine. We'll heat it up a little bit with a hot water bath. I'm going to place it into another container. This is a photographer developing tray, and it has these ridges on the bottom which allow water to flow underneath. So I'm going to place it inside here so that if the solution gets too cold, I can pour hot water on the outside to slowly heat it up by a relatively controlled amount. Just going to try and mix some of these crystals in. So now we can see that's fully dissolved in. I'm gonna grab my bottle of hot water on the side here, or my flask of hot water, and just put a little bit into the base here. You can see that we basically have some hot fluid around the outside. This is measuring it at sort of 73 or whatnot. Our fluid on the inside is sitting at 36, so that's a little bit cold for my liking. I would like to get this up to at least 45 to make the process a bit faster, so I'm going to add more hot liquid on the outside. We're starting to warm up a little bit. Our fluid here is roughly 38 Celsius. So now we place the board in here, and when you first put it in, so the copper starts off glossy and shiny. When you first put it in, and it's quite useful to watch where it turns matte, because anywhere it stays shiny, that's a location where you did not properly remove your solder, your etch resist. And so that kind of can help you work out next time what you did wrong. So for example, at the bottom of the board here, where you can see there was a green shadow, it stayed shiny. So that's going to be a part of the board that's going to take longer to etch. So this is a fairly slow process, sitting here and waiting for this to etch. This is a sodium persulfate etching solution. I'm using this because a lot of people use ferric chloride. Ferric chloride is quite messy. It's very dark brown, and it stains clothing very easily. And so this solution is supposedly better because it's colorless. The problem is, if you spill this on your clothing, you won't know that you spilled it on your clothing. At least with ferric chloride, you'll see a stain, and so you'll know that you need to clean it. And I have often spilt a drop of this persulfate on my jeans or something like that, and you come back after you've taken it out of the wash and there's a hole that's just been burnt through from the chemicals. So now I wear a lab coat whenever I'm working with this stuff. Back when I lived in a third world country, I used to use cupric chloride, which is super easy to make. I would walk into my nearby grocery store, which the equivalent of an American Safeway, go over to the pool care aisle and get a bottle of fuming hydrochloric acid. And then I would go home and I'd put a couple pieces of copper in the fuming hydrochloric acid, and go off to the nearby chemist and get some 60% or 80% hydrogen peroxide, add a bit to put a bit of oxygen in the solution, and you get a cupric chloride solution, which is it's a light, almost fluorescent looking green. And when you put copper in it, like a copper PCB, it turns darker green as the ions change and it etches the board. And then to reuse the solution, you just aerate it. You bubble a bit of oxygen through it, or bubble air through it, and it turns bright green again, and you can keep reusing it. So basically it just gets stronger and stronger, and you can keep reusing it indefinitely. So it's very cheap, very useful, and you don't have to worry about getting rid of hazardous chemicals, because you just keep the same bottle and you keep reusing it. So when I first came to America, I thought, okay, I need to etch some PCBs, I'll do this. So I went to a supermarket and couldn't find any hydrochloric acid, and I asked a person there, oh, where can I find some hydrochloric acid? And they looked at me like I was some kind of terrorist. Man, in this country, you cannot do that. So I couldn't find any hydrochloric acid anywhere. I couldn't find any way to buy it without some kind of license. Similar thing with hydrogen peroxide. You go to a pharmacy here and I couldn't find any decent hydrogen peroxide. Go to the counter and ask, hey, do you have any hydrogen peroxide? 60% or 80% would be ideal, but I guess I could use 50. And they look at me like, are you crazy? The strongest we have is like 1.5%. It's just really diluted, and that's no bueno. You can't do anything with that. So this is kind of why I'm using this set of chemicals. It's what I can actually get here. Similar thing with hypodermic needles. When you're soldering these small TQFPs, if you accidentally bend a pin, the easiest way to straighten out a pin is to get a hypodermic needle, and you blunt the end of the needle so there's a tiny hook on the end. You basically just scrape it against the metal surface or something, and then that tiny hook you can use for straightening the pin. So I walked into a pharmacy and said, hey, can I get some needles, please? And they said, do you have a prescription for that? Like, you need a doctor to write you a letter to buy needles. And I don't understand that. Why would I need a prescription to buy needles? I mean, in America, I can buy 40 pounds of gunpowder online and get it shipped to my doorstep, but I cannot buy a hypodermic needle? Does that make any sense to you? Anyway, the other nice thing about cupric chloride is it's extremely fast at room temperature. If I had been etching this board with cupric chloride, you would probably be finished etching in about 40 seconds. And ferric chloride, I've noticed there's some cunning systems online with ferric chloride where it's kind of a sealed plastic bag, I guess, kind of like a Ziploc bag, and you put your PCB in it and you fill it with your ferric chloride, and it's all entirely sealed, and you kind of massage the bag to etch the board, and then that's a lot cleaner. So I guess I could do that, but I now have a huge stockpile of these persulfates chemicals, so I'm going to stick with this. Now I can feel with my hands that this solution is adequately warmed. If it starts getting cold, you do slow down, but this is at an okay temperature. We should start breaking through the outer layers in a little bit. Another thing that I've seen has become popular in the makerspace for making PCBs is these milling machines, like end mill or other mill or whatever they're called. In my opinion, those are just not worth it. Not only are the machines expensive, and you have to design your PCB in such a way that it will actually work on the machine, because they don't have very good resolution. I mean, you can't do 5mm traces on a milled PCB, which you can very easily do on an etched PCB. But it's just a pain. You have to keep buying new drill bits and stuff, and yeah, I guess with etching you need to buy new chemicals, but it's pretty cheap. And I get very good yield and a very good looking final product on etched PCBs. So I recommend, if you're wondering how you can do PCBs at home, I would try the etching route. it's not as bad as people say. So as you can see, we're starting to break through here, and assuming we're getting a relatively even etch, which we do appear to be, it starts to etch through around the sides first, and you can see in the middle of the PCB we're starting to change a bit of color there. So I'm just going to keep going. For this particular PCB, it doesn't matter to me if the back over etches, so I'm just going to look at the front here and keep going until that's done. Even if your board doesn't have a ground plane or doesn't require a big ground polygon pour, it's worth doing it. Even if that net isn't connected to anything, because it makes your etching quite faster. You can see all of the area around the traces here is done. I'm waiting for this copper in the middle to etch, and a similar thing happens if you have large pieces of copper that you have to etch off your board. So if you don't require the copper to be etched off, it's worth just putting a polygon there so that the copper stays there, so that the etching is easier to control. You can stop sooner. You don't have to remove as much copper. I'm not too sure why it's so different when you have to remove less copper. I don't think it's because the solution gets used up, because I could etch far more PCBs with the solution once I'm done with it. I think it's got something to do with the flow of chemicals over the surface or something like that, but it definitely works much better if you're only removing a small amount of copper. In fact, what I would often do, and I didn't do it this time, is put tape around the outside so that I don't remove all of this copper on the side. So put tape when I'm developing it, or exposing it rather, not developing it. So this is the copper around these holes here seems to have been removed adequately. I don't care about the copper around here. And on this side, the copper seems to be removed in all of the places I care about, so I'm going to stop here. It's best if you've got fine detail, which this isn't fine, these are 12mm traces, but for 6mm traces or 8mm traces, it's best to stop as soon as you're close to being done. So I'm just washing this in water on the side here, and I'll clean up the chemicals and then separate these boards out. Just a note, if you look at the tips of my gloves here, these are nitrile gloves, you'll see that they've started to change color. The same thing happens with your skin if you do this without wearing gloves. So rather do it to the gloves than to your skin. So now I'm just going to dry the PCBs with some paper towel here and inspect them. At this point, it's actually not too late to put it back into the developer if you notice some poorly developed areas, but this looks fine. For this next step, I'm going to remove the green etch resist with acetone. You don't actually have to do that. It melts when you solder, so the flux in the solder pushes it off, and it makes a good bond with the copper anyway. But it makes the final PCBs look a bit ugly. You get these pools of green etch resist all over your board. I'm not a big fan of the aesthetics, so I'm just gonna liberally apply some acetone here, and it just rubs off. So now we're left with nice, clean, etched copper PCBs. Now I'm just going to depanelize these boards, and the easiest way that I've found is just to use one of these small table saw thingies. I don't know what the correct name for this tool is, but they're pretty cheap, and they're quite good at cutting PCBs. You can actually cut these with scissors as well. My colleagues do that a lot. I haven't really tried that, but oh, actually that's way easier. Never mind the table saw. Really, the only part of this board that's important to cut close to is the USB. Depending on the type of USB socket you're using, sometimes they hang over the edge of the PCB a little bit. I think mine does hang over by a small amount. You don't absolutely have to get it nice and close to the edge, but it does look nicer. Right, so here are 4 PCBs, and we only needed one, but I'm going to take a look at this under the microscope and check if any of these have traces that didn't come out nicely or some kind of defects, and I'll just pick the best one and just use that going forwards. So I will say that the scissor method is much faster, but it does give a bit of a bend to the PCBs. The table saw doesn't do that, but it's much harder to cut this close to the board, especially if you're cutting something small. These PCBs are kind of medium sized, but if you're cutting something very small, it can be a bit of a pain. So I'm trying to get it so that you can see the board through this microscope here. It's quite difficult to get the camera to see through the microscope, but you can see that the quality of the etch is pretty good. There might be some stuff between pins there that we need to double check. Normally that's such a small piece of copper that you can clean it up with an X-Acto knife or something. There we go, that's not too bad. So you can see it came out relatively well. Okay, so I've taken the boards and I've gone through them and looked at them under the microscope. One of them was perfect, and the other 3 had slight under etching problems between the pins there, so I've just taken an X-Acto knife and cut between those pins. And now I'm just going to... Now I have 3 boards which are good. One of them is not really worth fixing, seeing as I only need one. So this is the good, like absolutely fine. These 2 I had to do some small fixes on it with an X-Acto knife. Now I'm gonna drill the vias. So I just have some 3/64 drill bits. I basically just keep a bunch of these around, and I get a new one each time because they go blunt super quickly and they're not expensive, so it's worth just taking a new one out. Actually, I just switched to a 1/32 here. It's better for the vias. I normally use the 3/64 for header holes. And I just have an average sort of Dremel. It's worth wearing eye protection when you're working with these things because these drill bits snap pretty frequently. This is very difficult to do with the camera here. I might have to do this a little bit off frame. Okay, so I've done all 3 boards, and the registration is pretty terrible because it's actually quite difficult to do this with a camera. I'll have to look at the footage, but I'm pretty sure I had it all out of frame. Normally my registration is a bit better. I guess if I had a drill press or something, a good quality drill press, I could get better registration, but actually I find, like, see, this one's pretty bad. I need to be very careful when soldering that, not to short that to the ground plane. Yeah. So for vias, what I recommend is just getting, a dead LAN cable. We, always have a lot of these lying around. Someone rolled their chair over this or something. Make sure it is a solid core type and not a stranded type. And then get a decent length of it, depending on how many boards you're doing. Maybe like a foot or something. If you're really lucky, you'll get one of those cables that have a little Kevlar strand in it that makes it very easy to strip. This one appears not to have the Kevlar strand. So I'm just going to use an X-Acto knife to cut down the side of the cable. You don't really need to go all the way, because you just need to free up enough that you can grip the conductors in the middle, the wires in the middle. If you have a short enough cut, short enough section, then you can just pull it through the insulation once you have that. There you go. I'll just take these, unwind them. Now for stripping the wires, just get each strand of wire and get one of these automatic wire strippers and kind of pull back the conductor every couple inches. It just leaves a little, if I can get this to focus, it leaves a short section there where the conductor is being pulled back. This particular cable appears to be quite bad quality. You can just feel from the insulation on the inside. Then to strip it, you just run your hands along it like this with a bit of friction, and it comes off in chunks. You can see it, the end chunk has already come off. You don't need to rush it, just keep running your hands along it, just gripping it lightly, and it slowly moves off in pieces. So here we go. Now we have our first section stripped. And this may be enough for the boards, but just for the fun of it, I'll do another one just so that we have some extras. And I recommend using network cable for this, even if you can just buy wire, because the network cable is just so cheap in comparison to buying special purpose harness wire or something. Now I'm just going to cut this into roughly inch long segments. It's not really important that they're an inch long, but it is extremely useful if they're all roughly the same size. So now I'm just going to solder the wires through the vias so that I can basically solder them on both sides and they keep the top and bottom layer connected. And I don't have many vias on this board. All of the big hexagonal ones are actually connectors for external cables. So I have a via here, here, there, and there. I think it's just the 4. So get something to prop your board up off the table. I'm just using some like CR123 battery pack connector thingies that I have lying around. And prop it off the table and place your copper wires through all of the wire holes. This is why you make them an inch long, so that you can prop them off the board, off the table with almost anything and still have it properly connect. Now you don't have to do all of them, you just need to do enough that you can prop the board up on the wires that you have soldered in. So I can't do all of these because some of them are gonna collide with the thing I'm using to prop the board up, so I'm just gonna do a handful here. It's normally easier if I can see what I'm doing, but having a camera does make things a lot more complicated. And once you've done that, you can, the wires on the bottom are all roughly the same length, so you can prop it on those wires directly on the table. You may need to bend some of them to give a better joint. I can see that one was a bit of a dry joint. This one on the right hand side was problematic. I did not have very good registration there. If you make a mistake with accidentally shorting one of your vias to the nearby ground plane, you can just clean your solder tip and just clean it up. If that happens to you very frequently, you should change the isolation amount on your ground port to pull back from your vias more so that you don't need to worry about it as much. So now once you've done that, if you cut all of your wire lengths perfectly the same length, you can just flip it over and do the other side. Unfortunately, I got a bit lazy this time, so I did not do it perfectly. So I'm not going to trim them so that the board is sitting at least a little bit level when I turn it over. I apologize for the exposure, it's pretty difficult to get right. I'm soldering onto a ground plane here, so this takes quite a decent soldering iron to be able to locally heat up the area. I didn't put any thermals, I think it's called thermal relief or something, where around your via pad you have little bridges to restrict the amount of thermal flow you can get. I didn't put any here because sometimes those are a problem when you're etching, and also this particular board, you know, I simplified this from a board that I already had, and it's designed for high power, so I didn't add any of those because I didn't want those to cause a problem, be like a localized hotspot when I was running 20 amps through them or something. So I'm still concerned about this one here. It was way too floppy. If it had properly connected on the top, it should not have been that flexible. So I'm just gonna extend the solder fillet all the way up onto the wire just to guarantee that it's a good connection. There we go, something like that. Alright, so that's one board done. I'm going to do the other two in much the same way, and then I'll continue from there. So I've done both boards and checked them under the microscope, and all the via joints seem pretty good. I have a suspicion though, you'll see the ground plane is discontinuous here on the side. Pretty sure that was not meant to be discontinuous, so I'm just going to quickly short that across. Might have happened when I moved the outer dimension of the board in or something. I just accidentally removed that. So the trick is, when you're trying to deliberately create a short, is to keep the soldering iron there for long enough that the flux burns out, because while the flux is still there, you're not going to be able to get it to short, because it's the whole point of the flux is to stop it from shorting where there's no copper. Of course, it would be ideal if it didn't also short to the pin that I have here, because that's not supposed to be connected. If I can't get this right, I'll probably just put a piece of wire across here and solder that on. Yeah, it looks like that's what I'm going to do. I'll just use one of these pieces of copper I have left over from all the wires. Okay. Now I'm going to solder the MCUs on, and the rest of the components, and I'm not going to give a tutorial on that now because I'm going to do it when we get the nice PCBs in from China. When you're soldering on homemade PCBs like this, I mean, it's mostly the same procedure, except it's a little less forgiving because you don't have solder mask, and I'm not confident that I can do it while also attempting to film it, so I'll defer the attempting to film it and show you how to do it with the actual real PCBs. These I'll just do quickly off camera. Thanks a lot for watching. This is what the final PCBs look like. I'll be continuing a bit more later when the actual real PCBs come in from China, and I can show how those look and how they get assembled. I'm sorry about the poor camera quality. I'll try and get some better equipment soon. Thanks.